So here we'll discuss a couple of methods of solving exponential equations, but to begin with, let's see what an exponential equation is. So if we have, for example, e to the 3x plus 2 equals e to the x plus 1. Notice that that's in the exponents place, and the minute you see an x in the exponents place or an unknown in the exponents place, that becomes an exponential equations, because here we're solving for x and x is in the exponents place. Same thing here. X is in the exponents place, so it's an exponential equation. Look at the next one, e to the 2x plus 3. The minute you see an x in the exponents place, you can call it an exponential equation. Same here and here. Now we'll look at the two, or before we go on to that, let's just look at what is not an exponential equation, what you wouldn't call an exponential equation. So let's look at this, x squared. Look at the exponent, that's a constant. Look at the exponent here, that's a constant. The exponents here are constants. They do not contain an x, which is the unknown. So therefore, that's not an exponential equation. Here, the first one would be a quadratic equation, because the degree of x, the highest degree, or rather the highest exponent on x is 2. And here this would be a linear equation because the exponent on x is 1. Now the two main types of exponential equations we see here. The first type is when you can put the equation in the form a to the something. A is the base, a can be any number. A to the something is equal to a to the something. So notice that this is an exponential equation. Let's assume it is, which means one of these, at least one of these exponents will contain an x or an unknown, whatever the unknown is called. In this case, we can use the one-to-one property of the exponential function. If a to the something equals a to the something else, then those two exponents would have to be equal. So this is one of the two types that we're going to look at here. And the next one is the second type, which is when you have an exponential equation that looks like a to the something, which contains an x, because it's an exponential equation, x or whatever the unknown is called, equals b. In this case, we would have to convert it to a log equation. So this would be log of the number b to the base a. So the base is always the same. So you can see the base of the exponent is the base of the log, is equal to the exponent. So log of the number b to the base a is equal to the exponent. So this is how you convert it to a log equation and then solve it. You convert it to a log form rather, and then solve it. Now let's look at the examples here. Now we can classify them as type A and type B, and of course there's one that is neither. We'll look at that. So we look at the first one, e to the 3x plus 2 is equal to e to the x plus 1. So here clearly we can put it in the first form, e to the something equals e to the something. We can use the one-to-one property and solve it. So that's type 1. Let's look at the next one. 4 to the x equals 4 to the 4x plus 1. We can convert it to the first type by adding 4 to the 4x plus 1 on both sides. And this converts to the first form where we just equate the exponents. Now we look at the third example. This converts to the second form, e to the function of x equals 5. So that would be the second type where the exponential function has to be converted to a log function to be able to solve it. This again is the second type because I can add 7 on both sides and then it'll convert to the form 3 to the 4x minus 3 equals 7, and that converts to the second type of equation that can be solved by converting it to a logarithmic equation. Now this one it's neither 1 nor 2, but it can be converted to a quadratic form and solved like using the method of solving quadratic equations. Here we, let's say, call e to the x, call it y, and it looks like y squared plus y plus 1, and then we can try to solve it using the techniques that we use in solving quadratic equations.